Hello everyone, welcome to Chem 112. I'm Professor Martinez, and today we'll be discussing organic glassware and how to prepare common pieces of organic glassware from commercially available 7-inch pipettes and a burner. So, common pieces of glassware that we're able to prepare in the organic chemistry laboratory for our use, first and foremost, are melting point and boiling point capillary tubes. You can prepare these rather than buying them commercially. We can also prepare microcapillary bells, which are small pieces of glassware designed to go inside the capillary tube. We'll show you a close-up of that later on in today's experiment. You can also prepare spotters for TLC and other sampling of your organic reactions. Additionally, you can prepare, and this is really cool, you can prepare a stir bar using a paper clip and a 7-inch glass pipette. These are very useful for running chemical reactions rather than having to buy the Teflon stir bars. Finally, and one of the more important pieces of glassware you'll be preparing, is what's known as a micropicnometer. This is a relatively large version of a micropicnometer, and we'll prepare a smaller version today in our live demo. A micropicnometer is used to measure small microscale volumes of liquids, and it's used to measure the density of organic liquids of a discrete volume. Okay, so we're going to get started today with a sample glass shaping demo in which we're going to take our typical 7-inch pipette and we're going to shape it into, first and foremost, the raw materials for a micropicnometer and the raw materials for a capillary bell. So, first and foremost, we also need to make sure we have a pair of tweezers handy. Additionally, we also have an additional metal file used to break our glassware and score our glassware to efficiently break without shattering. And we have a series of paper towels to lay our materials on to allow them to cool. Okay, so let's get started. First and foremost, we are going to start our burner. Now, it's really important that if we stare closely at the flame, we want to make sure our glassware is in the hottest portion of the flame, the edge of the inner blue cone. This burner is slightly different than the micro burner that you're going to be handling in your laboratory in that it has a splitter and it has 3 discrete small flames. We'll be holding our glassware in the edge of the inner blue cone in order to have the most efficient heating process. So, we're going to focus on heating right above the bulb of your pipette. You want to heat in this region so that way when we pull our glassware we end up with a nice micropicnometer bulb as well as a long tapered layer that we're going to use for our micro bells. Okay, so now we're going to begin and we're going to pull the first components of our micropicnometer and the components needed for our capillary bell. We're going to heat our pipette just in front of the point where the glassware begins to taper, and we're going to carefully swirl and move both ends of our pipette, keeping it immersed in the hottest part of the flame. As the glassware becomes more and more malleable, it'll eventually reach a point where you can pull and bend and extend the glassware, and we're going to pull our pipette as we take it out of the flame. As you can see, we have a long, thin piece of glass that we're going to use for our capillary bells, and we have a region at the tip, at the end, that we're going to use for our micropicnometer. We're going to allow this glassware to cool, and then we'll continue by showcasing how to prepare a melting point and boiling point capillary. So now we're going to showcase how to take a 7-inch pipette and generate a melting point and boiling point capillary tube. Well, the first step in this process is we're going to very carefully heat the tip of our pipette until the tip is completely sealed. We only need to gently immerse it in the flame, and we're going to very carefully roll the pipette back and forth as we immerse it in the flame. If all goes well, we should end up with a nice seal in which there are no air bubbles. This can be checked after cooling via the application of water, but as you can see, the tip of the pipette has a very nice seal, as there are no gaps in the seal at the bottom, and there's a clear bulb of glass at the bottom of our pipette. This can be loaded with solids or liquids and will be processed further in order to generate a both evacuated and an unevacuated capillary. We're going to use a similar process in the next few minutes to prepare a sample stir bar. What we're next going to do is we're going to set the stage to prepare a stir bar. So from this, we're going to take our 7-inch pipette, and again, we're going to seal the end of the pipette using our burner. So we're going to carefully move the tip of the pipette, rotating it to make a nice seal with no air gaps at the end. You want to make sure to not leave it in the flame for too long, or it will start to sag. So here we have a nice complete seal at the tip of our pipette, and I prepared for our stir bar a paper clip. So we're going to take our paper clip and we're going to load it into our pipette. So now we have our stir bar magnetic component at the tip of our pipette, and now what we're going to do is we're going to seal off the end very carefully, and from there we'll have a nice complete stir bar. So we'll allow this a few moments to cool, and we'll continue on with our picnometer step. So we have our precursor to our picnometer. Now what we're going to do is we're going to taper off both ends of our picnometer and smooth out the glass ends on both sides of our picnometer. So first and foremost, we're going to be really careful, and we're going to seal and taper off the bottom of our picnometer by very carefully sealing off the bottom using our flame. Okay, now that our bottom's sealed off, we're going to trim and taper off the bottom in a second step once it's cooled. We're also going to taper off the top of our picnometer, holding our picnometer on one side with our tweezers. We're going to very carefully pull off the top portion of our picnometer, and now we're going to taper off and smooth both ends to get a complete picnometer. This is a relatively large picnometer, and I can show you an example where we pull an even smaller picnometer towards the end of today's session. We're going to allow this picnometer to cool, and then we're going to trim the ends of the picnometer and smooth them out to get a complete microscale picnometer. So here's a completed picnometer that I pulled in a separate trial. Notice how it's quite small. It's mainly designed to hold around 50 to 200 microliters of liquid. The bottom end is completely sealed, and the top end has been flame polished. So this is what the completed picnometer will look like. We'll continue working on the picnometer that we've prepared, and we'll showcase the final product later on in this recording. So as we allow our picnometer to cool, what we're going to do is we're going to take our cooled down stir bar precursor, and we're going to taper off the opposite end of the stir bar in order to generate a complete glass and metal stir bar. This can be used for organic reactions. So we're going to very carefully heat the end closest to the tip of the stir bar, and we're going to allow it to seal. We're going to allow it to sit and cool, and as you've noticed, the seal on the end isn't perfect. So we're going to run this through the flame to polish it down and make sure that the edges are completely sealed. The last thing we want is our reaction mixture going into our stir bar. Okay, so we've sealed off the end. We've made a nice bulb. And you can check that their stir bars are completely secure by, once they are cooled, immersing them in water. Okay, so we have this long, thin piece of glass, and we're going to shape this long and thin piece of glass into a series of capillary bells. So to do that, we're going to break off a small piece from this long chain, and we're going to seal off one of the ends of this capillary bell. We need one end to be completely sealed while the other is open, so that way we can observe and we can collect a vapor pressure inside our capillary bell. When we're measuring the boiling point of a substance, we're going to be viewing and looking for the emission of bubbles from our capillary bell in order to mark and indicate the boiling point of our substance. So, using our designated glassware scorer, I'm going to score and break off a very, very small piece. And I'm going to aim for the middle as it has the thinnest piece of glass. So we're going to break off a tiny portion. You want the capillary bells to be simultaneously not too large that they don't fit, but not too small that the capillary bell is ejected when your substance begins to boil. So we've broken off, and we have a very, very tiny piece of glassware, but it has some weight, has some length to it. Now what we're going to do is we're going to taper off and seal one of the ends using our flame. Okay, so we've sealed off one end of our capillary bell. And just to show you how this all fits together, I'm going to show you how this capillary bell fits inside the microscale capillary that we prepared earlier. So we have our sample melting point and boiling point capillary. Now what you're going to do is you're going to take their capillary bell with the open end pointing down. The open end pointing down, and you're going to slot it into your capillary tube. Allow me one moment to do that. Now, if everything goes well, the capillary bell will fit inside your capillary tube, and it will be open end down. Notice you want your capillary bell to have a little bit of weight to it, so that way it doesn't get ejected when your sample boils. Okay. To continue off with the picnometer that we've left last time, we're just going to do a small aesthetic modification. We're going to trim this top piece of glass, and we're going to flame polish the edges. I'm going to trim off camera because... So we've trimmed the end of our micropicnometer using our glass scoring device. And then what we're going to do now is we're going to flame polish the ends of our micropicnometer. We always want to make sure the ends of our glassware that we've broken is flame polished, so there's no risks, or we've minimized the risks of cuts. Okay, so now we've flame polished the tip of our micropicnometer, but it is still open, and we're able to dispense liquids into our micropicnometer. The last thing that we're going to discuss is an in-depth process into how to prepare an evacuated or filled evacuated melting point tube. Note, you're only going to do evacuated tubes for melting point. Do not prepare an evacuated boiling point tube. So what we're going to do is we're going to load our capillary tube with a sample solid. So rather than using a sample organic solid in this case, I'm going to load it with a paper clip portion. Oops. So now that we've taken our sealed off melting point tube and we've loaded it with a sample solid, in this case a paper clip. And now what we're going to do is we're going to seal the top end of our melting point tube, assuming that the opening of our pipette was hooked up to vacuum. I don't have a vacuum line currently in this case, but the main way to check that you have a perfect seal at the end is if you apply vacuum and the solid does not move, you're good to go. We're then going to seal off under vacuum the top end of our melting point capillary, and that will give us an evacuated melting point capillary tube. So you're going to avoid heating close to the solid. You're going to heat away from the solid. You don't want to trigger undesired chemical decomposition at high heats. So we're going to hold far away from the tip, and it may curve like this. It's not uncommon for it to curve. You're going to want to make sure the opposite end is secure, and we're going to very carefully seal off. Okay. I'm going to continue to seal off the top end of our capillary. And I'm going to really make sure it's flame polished. Okay. So if you've done this properly under vacuum, both ends should be completely sealed. And if it's sealed under vacuum, the inner contents of our melting point capillary tube will be completely evacuated. We won't have any oxygen present inside our melting point tube, which will allow us to measure the melting point of substances that are sensitive to decomposition. So, just as a summary, just to cap out our project today, we've in turn prepared a series of micro-scale pieces of organic glassware. I'm going to turn off the flame. We have prepared, first and foremost, a micro-picnometer, which is designed to measure the density of micro-scale volumes of liquids. This is a large micro-picnometer that I prepared so it's easy for students to see. In the laboratory, you can prepare micro-picnometers that can even hold up to 20 microliters. Additionally, we have prepared examples of an organic stir bar containing a paper clip made from a paper clip and a 7-inch pipette. This is used for chemical reactions. So if you don't feel like buying stir bars, this is a cheap way to make them. Additionally, we prepared a sample example of an evacuated melting point capillary tube. So we showed example procedures for how to load your capillary tube with solid material and how to seal your capillary tube under vacuum. This is a technique that will be utilized in our caffeine analysis laboratory. Additionally, we've also prepared a boiling point capillary tube containing a small capillary bell. This is used for boiling point determination. Finally, we've prepared and we've showed how to prepare a TLC capillary spotter. This can be used to sample small volumes of liquid, and it can be used for thin layer chromatography monitoring of your reaction. So this is an overview and guide that I'd like you to reference throughout the semester if you're ever unsure how to prepare some of these common pieces of organic glassware, or if you need to re-prepare them after our organic glassware laboratory.